want to know the solution, let me know. Okay, so we will try to finish it early so that I can return back the exam paper to you. Okay, we have discussed about it, right? About the airfoil, how our airplane can fly out there. Now, if you look at the trend nowadays, both the biggest airplane manufacturer, Boeing and Airbus, they try to manufacture the wing from the polymer. The reason for that is because if you are using polymer, you can control the friction or the direct collision, and since you made it like a plastic, of course it is a carbon reinforced fiber, right? It is not like your sometimes you want to modify your old Saga into a new Saga, so you buy a fiber, right? You buy a fiber, you put it there. But of course, those fiber will not be the same way the fiber used by the Bugatti or Ferrari. Right? Most of those cars now is made of fiber. That's why if you see any accident involving Ferrari, it will burst. When it bursts, burn, you will see nothing. Right? Nothing, because it's made of plastic. But of course it is very expensive plastic, not the plastic that you have for your bottle or for your watch. It's totally different. Okay, nowadays the same goes for the aircraft. If you know the A350 and Boeing 787 and the newest Boeing 777X, they are all made of polymer, because polymer has a very good strength, right? If you look at the history, humans used to wear nothing when they go for war, right? They just go there using axe or sword, right? And then you just do like that, like a knife. But then after some time, they try to wear a heavy metal plate, right? Over the day, it's getting heavier and heavier and heavier. Then they cannot hold it anymore. Now, if you know, the modern soldier, they are using Kevlar, right? Kevlar is very thin. It's like this thin, but it is made from the polymer, and it's very proof. Like a bullet resistant. So even you hit those Kevlar, it will not be ruptured. So it can hold that thing. And it's made not from metal, it is made of polymer. So with the same concept, now the airplane manufacturer want to utilize this polymer. It is very strong, but at the same time it is very light. Okay, that's why they want to use it. So you need to control the surface of those. Okay. So the trend now is the wing getting longer and longer. Right? The reason is now you want to maximize the area. Okay, the Boeing 777X that you will see in the next 2 years will have a folding wing, just like your Super Hornet F-18 or F-14 that can fold. And just like your origami, you fold the wing, put it in your pocket. This aircraft now use the same concept. So this wing can be folded. When it's not needed, it will be folded. When it is needed, it will be like that. The reason for that is because they do not want to expand again the already very wide runway. Because overall, this runway can have a width of 60 meters. So you do not want to make it even bigger. So how to do that? You make it foldable. When you need it, it will be utilized. When you do not need it, fold it. That's it. So make it simpler. Okay. So we already know that during the takeoff, we want it to be as minimum as possible, the takeoff speed. Because if you need the higher speed, right, you need a longer runway, and longer runway means more expensive. Because not only you need to build the runway, you need to buy the land, you need to clear up everything, right? And also, if you realize near the airport there will be no high-rise building, right? Because it is a rule. If not, something like in Medan will happen. You know, the Hercules goes there and then one building there, slice it, just like slicing a cake. But rather than the cake that is sliced, this one is the aircraft that is sliced. Because this thing is very hard. Okay, so you see that it is not only about the runway, but also the area outside the runway. So if you need to make it faster, in the takeoff, which means you need a longer runway. If you need a longer runway, of course, the area affected by the runway will be. So you want to make the minimum takeoff, then the only way is to play around with this CL and area. Okay, and the area, if you want to increase it, you need to remember that when you increase the area or to get a higher lift, you will increase the drag force. So whenever you play around with FL, you will get the FD, right? Because this one is CL, A. This one is AD. Okay. So if you increase the area, right? If you increase the area, you will increase the FD. So you do not want it. You want it to be minimum also. That's why you introduce the so-called flap. Okay, this flap is there to help you extend the area. Okay, but at the same time, when you don't need it, you will reduce it. Okay, but this area, this increase in the area will not be counted in here, but rather it will be counted in the CL. It will not be counted in the area because the area is the area of the wing when the flap is retracted. It is not utilized. Okay? And then you will see that between the flap and the main body, there is a slot. What is the reason for this slot is to get the lower velocity air from down there goes up. The reason for that is you will get a reattachment. So your boundary layer will be. So rather than it will detach, because when it is detached, you will get aspiration point. When you start to have aspiration point, the wake region will be bigger. You do not want it. Right? You want the aspiration point to be as later as possible. So you disperse a little bit of air there, you will attach here, so there is no aspiration region. Okay, so the slot there is to give you that. Okay, sometimes there is a slot over here also to help that. Okay, and if you see the aircraft wing is not smooth, it is groove. Right? There is some groove. Okay, the reason for that groove is, if you remember, when we are dealing with the golf ball, you want it to be at a turbulent region for that particular speed. The reason is because if you get the region point at that particular speed, you know it will have a decrease in the CD. So all those things in the aircraft is not arbitrary. It is there because of those purpose. Okay.